How'd you do it? We'll start with numero uno then. So it's 24 points, and there were 6, so 4 points each. So number 1 was the sine of x cubed minus 5x plus 1. It's a trig function, so I'm going to do the trig first and then the inside, right? So the derivative of sine is cosine, and I leave everything the same. But then I come in and I multiply by, not this, but really it can go in front. 3x squared minus 5, and that needs to be in parentheses. And that is D. That was just straightforward chain. Number 2 asked for a second derivative. Tell me if I got too fast. The tangent of 3x. So I'm going to do the derivative of tangent first. The first derivative, which is what? Secant squared x, and my x is 3x. And then I need to chain it, right? So this is really 3 secant, and I'm going to write it like this so you see it. That's the same thing, yes? Agree with that? So whenever I take the second derivative here, I'm going to do power trig chain. So power first would be 6 secant 3x. Now do trig. What's the derivative of secant? Secant tangent, right? So secant 3x, tangent 3x. Now chain. So what do I have? I'm just multiplying everywhere. So 6 times 3 is 18. I've got 2 secant 3x's, so I'll just make that secant squared 3x. And then I have a tangent 3x. And I look at my choices, and there is one that looks like that. That's C. If it didn't look like that, I may could change the secants to 1 over cosine, the tangent to sine over cosine, and see if anything cancels, and I could rewrite any type of way. But since that one was one of the choices on there, I went with that one. Number 3. Is this the one you were talking about, Stella, one like this, or are you talking about, okay. G of x is going to be u, which is going to be 3 square root of x, and it says to find f of g of x at x equals 9. So here, if u and g are the same thing, then if I plug this in, I will have f of g of x, yes? Which is the same thing. This is the same thing as asking me. What the heck? This. Right. All right, so I'm going to plug in this here. So f of g of x is 3 times the square root of x cubed plus 1. Does everybody agree with that? So now take the derivative of that. Okay. Yeah. Which is going to be f prime of u, because u and g are the same thing. So the derivative here would be 9 times the square root of x squared. Yes, because I take one away. Agree with that? And actually, no. I'm going to write this a little bit differently. You see why I did that? Because I'm having to cube everything in here. I don't want to do 3 times 3 is 9. unless I'm squaring that whole thing. It's going to lead me into a little more chaining process than what I wanted to do. And I think it's a little easier to see it this way. Although that would have worked. Now I'm ready. I'm actually going to make this. So it's a little easier for you to see what's going on. Yes? It's still just over. Say that one more time. That is correct. Yes, what you says. Yes, yes, yes. And the reason is because I plugged in. Because see how this U right here is cubed? So everything I plug in has to be cubed. Yes. If this had been 3U cubed, you're exactly right. That 3 would be outside. It's still different. All right. Now I can plug in. So actually, no, I'm not ready to plug in. I have to do derivative, right? I'll just call it U. So you can see what's happening. So I'm going to multiply around, yes, which would be what? 81 over 2? Is that right? 27 times 3 over 2. So 81 over 2, x to the 1/2 plus 1. Are y'all okay there? What way did y'all do it? Now if I plug in 9, now what did I say, 9?
That doesn't work.
9 to the 1/2 is 3, so 81 times 3 is what? Is it? Oh, because I took derivative, that's right. I was going, wait, that's not right, yeah. You did end up with that? Yeah. I did f of g of x. So chain, if I do the derivative of this, it says do the derivative of the outside, right? Leave the inside alone. And then multiply by the derivative of the inside. That's the chain here, right? So what I'm really doing, g of x is 3 times the square root of x. The chain of this would be 3 over 2, right? You agree with that? So all I really have to find is this, f prime of 3 times the square root of x. Well, then if I look at it as u cubed plus 1, that would be 3u squared. And I'm plugging this in for my variable. In other words, you can find the derivative as it sits instead of plugging in that g into it. Does that make sense? It's a little more confusing way, I think, to look at chain, but it's still presented that way on AP a lot. That doesn't make sense. I can tell the way you're looking. Okay. F of u is u cubed plus 1. What is the derivative with respect to u here? 3u squared. Agree? Now it says that u is the same thing as g of x, which is 3 times the square root of x. Right? What is the derivative of g, which is the derivative of u? 3 over 2. That's u, right? All right. That's derivative of u. Well, over here, whenever you took the derivative of f with respect to u, I'm going to need to make sure I need to follow it with the derivative of u. Because remember, if I take the derivative of anything with other than x, I need to follow it with dy dx or du dx or whatever it is. So in other words, the derivative of u, which is here. Is this how y'all did it? Y'all said you did it different than me. You plugged what straight in? That's what I did. Oh, you did the same thing. You just went. I wouldn't advise going through this way.
Oh, there's two different ways to set it. Look on the right.
They're saying when they got here, they did power, which was 3 square root of x squared, and then they chained the inside here. Is that what you're saying? 3 over 2 x to the negative 1/2. And then you plugged in 9 at that point. I just made it where I didn't have to chain, I guess. Yeah, I did. That's what I was saying. Instead of, so they did, whenever they worked it, they said that they just chained it. So they left it, they did power and then did inside. Instead of doing that, because I saw it to be easier to say, well, since I'm multiplying, I'm going to do this. To get 3 to the third power is 27. Square root of x cubed is x to the 3 over 2. I just did the work on the front end instead of the back end. They did the work on the front end instead of back end. That's the only difference. Does that make sense? I didn't realize that one was so tough. That y'all had such a tough time with that one. You can't find it.
Yeah,
You know what's funny? Let me tell you, you'll laugh, Robert. No, you probably won't. Is what Mac was saying, the way he did it, and everybody else, that's the way I did it whenever I worked it out, and it's not the way I did it this time. So there's not a, I mean, I'm just saying, you'll do it different ways, different times, as long as you understand. Let's look at 4. Do y'all need 4? 4 is that implicit differentiation. Find dy dx if x times y equals sine x plus y squared. So let's derive. What am I going to do here?
Don't you find the derivative of everything and put the y, or put dy dx in front of?
Okay, so how are you going to find the product? Somebody said the product. That's the product rule, right? Derivative of the first times the second plus the first. What's the derivative of y? 1 dy dx. That's right. Don't ever forget that if you're taking the derivative of y. What's the derivative of sine? Cosine. And what's the derivative of y squared? 2y dy dx. And you're right, Robert, this is where I get all the dy dx's together and factor it out so that I can solve it for dy dx. So I think that I shall move this one over here and this one over here so that I have x dy dx minus 2y dy dx equals cosine x minus y. You like the implicit differentiation? I do too. I'm going to take a dy dx out. Oops, getting ahead of myself here. X minus 2y. Cosine x minus y, and I'm going to just divide. Hopefully one of the answers matches that. E. Sweet. What else? Number 5. So you're just going, what else? Y'all's mood is contagious. It's getting me all melancholy. Yeah, you know what that means? Melancholy? That's definitely the right word. Yeah. It's just like a ho-hum. Find an equation of the line that is normal to the graph, not tangent to the graph, at the point 2, 3. Tell me what to do. Find the slope. That's exactly where I'd start, slope. How you going to find slope? Yeah. Derivative. Find the derivative. So 4 plus derivative of the first, which would be 4x times the second, plus the first. What's the derivative of y? dy dx minus derivative of this one would be 2y dy dx, and the derivative of a constant is of course 0. Yep. If you ever take the derivative of y, it always follows with dy dx. The reason we haven't had to do it before, that's exactly right. There's just one y and it's y equals this, so it's dy dx. But again, that's what you're trying to find is dy dx. It just becomes 4. Derivative of 4x is 4. Right? Oh, yeah. So it's derivative of the first times the second plus the first times derivative of the second. So I did product rule. So since you have a point here, you can go through the work of solving for dy dx now, or you can go ahead and plug in and then solve for dy dx. It doesn't matter which one. Which one did y'all do? I did too. Solve it first. Or you plugged in? Okay. So I'm going to move these two over here. And while I'm on this side, I'm going to go ahead and take out a dy dx. I don't want to skip too many steps for you. You see where everything's from. 4 minus 4x. Everybody okay there? And then, of course, just divide by minus 4xy over 2x squared minus 2y. Now I can find the derivative at what? 2, 3? So derivative at 2, 3 is negative 4 minus 4 times 2 times 3 all over 2 times 2 squared minus 2 times 3. Which should give you 14. Negative 14. But that's not the slope I need, right? And notice that is a choice on there for a lot of the slopes is negative 14. But this is the normal line, so for the normal line, I do what? That's right, flip it and change the sign. So the slope of the normal line is going to be 1 over 14. And I have that 0.23, so now all that's left is write the equation. Y minus 3 equals 1 over 14. X minus 2. Did you do the tan?
I got everything the same except Friday.
I've gotten, and I didn't do this before I taught calculus and before I really started focusing on calculus, but if I have anything in the problem that's pertinent to what I need to do to solve, especially if I think it's going to be a long problem to solve, I always, and I can check, because I always work everything out with y'all before I do it, but I always circle so that before I go back and make my answer finalized, I'll make sure I've done everything. So that might be something to help you. Like I circled normal and I circled that point so I wouldn't forget that it was normal, not tangent. You underlined it? Oh, that's smart, Madison. Yes. But those are all good tips because, I mean, you don't want to leave anything blank, right? So if you can eliminate 2 choices just by doing that. Like if you look at A and D, the signs on the X are wrong anyway because it's a good way to work through some of the choices. Yeah, that's smart. Yeah, A, C, and D. So you got a 50-50 shot even if you didn't know how to, you know what I'm saying? If you just remembered how to write. That's a good tip. Good tip. All right, let's do number 6. Find dy dx if y equals 1 over. Y'all already know what I did on this one. In the very beginning of the problem, you did too. I just changed it right off. In fact, I didn't even go down. I just put equals to this. I feel like that makes my life so much easier. So now derivative here would be negative 1/2 x squared plus 1 to the negative 3 over 2. And then, of course, I have to chain it, so times 2x. The 2 and the half cancel, but it is still negative, and because this is negative, that's going to be on the bottom. So I've got a negative x up top, and I've got a, let's see, x squared plus 1 to the 3 over 2. And then I start seeing what matches. They're all in radical form, so maybe I need to change this to radical form to see it a little bit better. Or maybe you just saw the way it was there. And then the negative is just out front the fraction instead of hooked to the x itself, so it's b. Why? Oh my gosh. Yeah, but what a lot of work. Yeah. What'd you do? Yeah. You said you did something crazy.
Oh, no, I got everything right. I just didn't know how to put it into radical. I didn't know how to make it radical.
You didn't know how to sunshine it?
Yeah, I didn't know how that worked. But I have like that same answer you have. I just said a guess.
Did you guess right? Oh.
I actually have.
But you know the 1/2 is a square root, so the 2 on the bottom gives you a square root, right?
Like, oh,
So you got this.
I got negative. Yeah.
So which answer did you choose?
C. I don't know why. Because I know there's supposed to be an X. Cancel. I literally have those canceled. But I have the same like y1 as you. Like I have that. Cross it out.
Okay, so you know one thing you can do if you have time. Now I wouldn't do this. I would guess on my best guess if I was timed on the exam, right? But if I'm on the exam and I can come back to it, I would take, if mine doesn't look like any of the answer choices, I would take and plug a random number into my derivative and then plug that same number into these derivatives and see which one matches. Well, yeah, but if you have time, it's a good little technique. Okay, yes, no, maybe so. Y'all okay? Y'all ready to look at the homework from last night? I know, I'm sorry. I was trying to think because I was trying to get to what you were thinking of whenever you were telling me, but I wasn't understanding what you were saying, so that's why I just stopped with it and was like, whatever, bro. Yes. 1, 2. Oh, you're talking about the AP practice. 2 and 4B. 1. Oh, yeah. We're on page 194. All good practice, though. All good practice. All right. So switching gears over to your homework. The amount A in grams of radioactive plutonium Remaining, I always think about that SpongeBob. Did y'all ever see that with the Jerktonium? Do you know what I'm talking about? The Christmas special. My kids, when they were little.
Yes.
Okay, anyway, never mind. We used to have a DVD player in the car, and they had it like on repeat. And I've never sat down, probably, I don't think, and watched the whole thing. I could just hear it whenever I was driving, but I could probably quote the entire thing. Anyway, tough crowd today. Yes, it's Christmas. Sing it, Stella. But they all look like these felt characters. It's not like the typical SpongeBob. It was very weird. It was very weird. Okay, I remember that one too. Though.
Trying to get his crap. Trying to get his crap on the bridge. Like, it was like, see, they looked weird.
Yeah.
It was like that weird, like, filter animation thing. It looked like clay.
Yeah, like a claymation kind of thing.
Oh, I didn't know that was fun.
Really? Okay, so is the plutonic. So anytime you see rate, remember I'm thinking what?
Oh, that's third.
Rate. Slope or derivative, right? Or something along those lines. So at what rate is the plutonium decaying when T equals 2? So I'm looking for the derivative at 2 is what I'm really looking for. And answer in appropriate units, and they told me this is in 20-gram sample after T days, so my units I already know should be grams per day. If they specifically say make sure you use appropriate units, guaranteed you're going to get a point for units. So even if you get the answer wrong, write 5 grams per day. So you at least get a point on it if it's an FRQ type thing. All right, anyway, let's find the derivative first. The derivative with respect to T is this a calculator problem? I say that because it is rare. Yeah, it's a calculator problem. I would do in deriv. What?
What?
Because it said what's the rate at 2 days. Yeah. Page 194, number 59. At what rate is the plutonium decaying when T equals 2 days?
I didn't know. I mean, it was like after all the.
I will do this by hand for you, but I do want y'all, whenever you can use the calculator, I want you to start being a little more calculator dependent, because most of these calculator problems, you won't have time to do them by hand if they tell you can use a calculator, not to mention you probably can't. I've not seen a whole lot of these type of problems asked to find the derivative of, which is the form that this one's in, right? And that's the one, if you look at your derivative sheet, that's like a to the x natural log of a, and then I'd have to chain it, right? Are y'all following what I'm saying? I will show you right now how to put it in the calculator.
I know how to do the inverse, like, I'm not sure.
So when you're finding a derivative on your calculator, a specific value, I still tend to put it in y1 instead of typing the equation in. It's just my favorite way to do it. Let's see. Is this what? No, that's not what I go to anymore, is it? Do I have to do something new? No, that's not it. Maybe I do need the update. All right, so I'm just going to go into y equals, and I'm going to input this function. Can't see it, but my Chromebook is 20. Be very, very careful about, oops, I got coffee in my calculator, about these parentheses and stuff. All right, 1/2 raised to the t over 140. Now I'm going to come out, I'm going to go math, in deriv. I want it to take the derivative of, hit variables or vars, second quit or second mode. Then vars. Oh. Okay, math in deriv. Vars. And then over to y vars and hit enter for function. And we're going to choose just that y1. It won't yet. We're not done. Then we're going to do the comma, and we need to tell it what variable we're taking the derivative with respect to. And now you understand that a little bit better because we can do it with respect to other variables. But that's okay. All right, so I'm going to hit x because I definitely want it with respect to x. And then I want to know, I want it evaluated at a specific value. What value do I want it evaluated at? 2. So I'm just going to hit a 2, and I'm going to hit enter.
All right, I don't think it does not look at all like ours.
Let me see somebody's like that, and I'll put it up here. All right, there's your function, right? Everything's right. All right. I'm going to do math in deriv. I'm finding d dx, right? That's with respect to x. I'm going to put y1 here. I've already typed that equation in. You can always type the equation in after you call up in deriv. I just like to have it in y1 in case I need to do something else with it. I may need to graph it. I may need to look at it at another value. I like to have it there to reference if I'm looking for a problem. So I'm going to hit vars, over to y vars, function y1. Come over, and then this is where you say I want it evaluated when x equals what? 2. That's the same. These type yes. If you're, that's what I say. The ones that are like a number raised to a variable where you have to do that a to the x log of a, I've not seen those. I think 99% of those are calculator. Bars and then scroll over 1. Thank you, sir. So that becomes a quick and easy solve problem, right? Because it's negative. And this would definitely, I mean, you would definitely have your calculator for this because even plugging in and stuff, I would say that that's, I mean, you're not going to get that by hand. So if you've already got your calculator, why not use it to do the derivative for you? Grams per day, yep. It's probably not going to be anything. Yeah. Did they do it by hand? I mean, do you want me to show you how to do it by hand? Okay, so if you found the derivative of this, this is what they're basing that on. Right? That's how you find the derivative if you've got this number in the bottom. All right, so I'm going to keep that 20 outside, and I'm going to say that the derivative of this is, leave it the same, 1/2 t, I'm actually, okay, I'll leave it like that, 140, times, now I need to chain it, right? And I need to chain, oh, nope, I still got to do log of a, sorry. Log of 1/2. Now I chain it. Because my x is t over 140. So what's the derivative of t over 140? Which is, think about this, t over 140, I could really write as 1 over 40. 1 over 140 t. Now what's the derivative of that? 1 over 140. We should get the same thing whenever we. Your whole answer should be negative. But theirs is not. Oh. Yes. Oh, because yes, you're right. That would give you a negative value. Yeah, which is going to make your whole answer negative. So if you plug in here, if you plug in a 2 here, you're welcome. And you go through, again, you're still going to have to use your calculator. So use your calculator for the derivative too. You see all these places I could have messed up? Gross. Yes, absolutely. I want y'all to start using that more than what you do now, if it's a calculator problem. I mean, we want to be able to do them by hand, but we also want to be able to use the calculator for ones like this. So start noticing which ones are gray and which ones are not. Sophia's fixing to fall asleep. Don't fall asleep on me. Gray means no calculator, and then non-gray means calculator. What else? Which one? 65. Yeah. Oh, I didn't mean to give you all that yet. That's okay. 65. Flu is spreading at the rate of. Okay, so be very careful because read that carefully. What's it say? Flu is spreading rate. Rate is the key word there. What does that tell me? Slope, right? It says it's spreading at the rate of. That means this is already the derivative, right? Which of the following is the initial number of persons infected? So you can just plug it in because it's already the derivative. So just plug in 0 for t. Again, oh, this says non-cal. Okay, that is a lie. There's no way this is non-calculator. We talked about this one too, didn't we? Because I said this. I remember saying the same thing. I mean, you could, looking at the choices that are given, you could kind of estimate it in your head and go, okay, this is 150. 2.7, so close to 3. 3 to the 4th is what? 81. So over, but I overestimated, so somewhere around 80. What's that going to be? I still get close to, yeah, so that's not a good way to do it then. You need a calculator. You definitely need a calculator with E. You might have. 150 divided by 1 plus e to the 4th. Yeah, or 2.7. Yeah, that's right. That's right. That's exactly right. Can't have a 0.7 of a person. You said 66? Yeah, hold off on that one for just a bit. Put a pin in it. 2. So these are probably the most important in all the homework, in my opinion. It's 1 through 4. Everybody good on 1? All right, 2. Let f be the function defined by f of x equals x cubed plus x, and let g of x be the inverse of x. G of 2 equals 1. I'm gonna go about this a little bit differently than what I've been going about it. All right, so it's asking me what's the value of the derivative at 2. So let's think about this for just a minute. I'm gonna do a little t-chart. This is gonna be f. And then I'm gonna do g. Now g is the inverse, right? Tell me what the inverse does. Flips the x's and the y, right? So I'm not going to plug anything in. I'm not going to do it. I'm just going to look at what they gave me. They gave me this 2, 1, right? So I know if I go backwards on that and I flip x and y, then in the original function, that point is what? 1, 2. Everybody okay there? What I want is this slope, yes? Because they said the derivative of g at 2. So let's think about what I know. I know that these are just the flip of each other, right? The x becomes the y and the y becomes the x. So this, if this is rise over run, that's my change in y over change in x, yes? But I don't know that one. However, what I can find is I can come over here and find the corresponding slope here. Same way, right? It's my change in y over change in x. But if I want to get from here to here, all I would need to do is what? Flip that over and switch those x and y's, right? So if I can find the slope of the inverse, then I can just flip them over. Does that make sense? So then my question becomes, what is the slope of f, not at 2, but at 1, because it's the inverse, right? These are the 2 points that kind of go together. They correspond on the inverses of each other. So what's the slope of the original at that point? Well, how are you going to find that? Why would you put 0? The next one over? Oh, and you're finding the slope. What about even easier? Look at the equation you've got. What's the derivative of f? Look at what f is. F is this nice polynomial, right? The derivative here, remember, if you ever get stuck, take a derivative. It'll probably help you do something. 3x squared plus 1. Well, that's pretty easy just to find this derivative of, right? Derivative at 1. So if the derivative is 3x squared plus 1, then the derivative at 1 is 3 times 1 squared plus 1, which is 4. So if the slope of function f is 4, if that's change in y over change in x, then what's the slope of the inverse of that? Flip x and y. Make it change in x over change in y instead of that. And so you'd have 1, 4. That was defined in the beginning. Yeah. That's okay. It's not derivative, it's inverse. Sorry, I read it wrong. You're right. Say again. Y'all were both saying something at the same time. What? The same thing, yeah.
I'm just trying to figure out how you got 1, 4.
Yes.
It's 2.
Tell me what inverses do.
It goes from 1 to 4.
Just flips. It just flips.
What?
4 over 1 flips to be 1, 4.
So you're talking about what you got there. I didn't know that was split.
Yes. Here we go. A little particle motion. Calculus viewing pleasure today. Notice my restriction here. This is very important. I sense a unit circle coming up. Clearly, y'all didn't do this one if you didn't realize that was you. All right, find each time t when the particle is at rest. So my first question is, how do you know when a particle is at rest? Not even whenever it changes sign, but just when it's 0, right? It changes direction when it changes signs, but to rest, it just equals 0. So what I need to know is, when is velocity equal to 0? That's my big question. Since I have position, I need to find the derivative, right? The velocity. So the derivative of position is velocity, so I need to find the derivative of this. Derivative of the first times the second plus the first times what's the derivative of sine t? And I need to know, when does this equal 0? I got ahead of myself, I'm sorry. I factored out an e to the t here. And I'm going to think about that zero product property, okay? I've got two things multiplied together to give me 0. One or both of them must be 0. So I'm going to set each one to 0. E of t equals 0. What value would t have to be for that to be true? So e to the first is 0. E to the e is 0. What are you saying? E to the first is e. It's a bit of a trick question. It's never going to be. It can't be. It can't be. So that leaves me only that this, in order for this equation to be true, that's the piece that has to be 0. Because the first piece is, it's kind of like having a 2 out front. 2, if you pulled out a 2, that's never going to be 0, so it doesn't impact my solution, right? But the sine of t plus the cosine of t could be 0. So now I have to think, how in the world am I going to solve that and find that? How? Which ones, between 0 and 2 pi, which is the entire unit circle, right, all the way around, which ones, if you added the sine and the cosine values together, if you added the x and the y together, would give you 0 when you add them together? That's exactly right. There's definitely going to be an over 4, right? Because the over 4s have the same value. But I got to find the ones that one's positive, one's negative. They're going to have the same sign here and the same sign here, right? Positive, positive, negative, negative. So it's this one and this one. So now the hard part, remembering what those values are. 3 pi over 4 and what?
I'll do everything but that.
Robert, don't say that. That's an easy part if you get to that point. Like, there's no, don't get to this point and then you can't finish it.
No, I didn't get to any point. I'm saying I was.
Don't skip anything. You get
I mean, I'll
points
probably, like,
for. Remember what I keep saying, always take a derivative, you'll probably get a point somewhere. Even if you've taken a derivative, at least you've gotten somewhere. That was just the derivative of the one equation that was given. Take a derivative. Do something. Do something calculusy. That was just part A. Part B was the funnest. This is a typical part D of an FRQ. I have already found, so if you look at this, it looks quite intimidating, but I already found this. This was given to me. I just have one more thing to find, and really that's just acceleration, right? All right, so let's plug in what we know, and then I'll come back to that, what I need to find. All right, so I've got a times the second derivative plus. The first derivative I found to be what? That e to the t sine t plus e to the t cosine t equals, and then my original equation was e to the t sine t. Everybody okay there? All I did was plug in the work that I've already done, right? All right. I need to know the second derivative. So I know the first derivative. I got e to the t sine t plus e to the t cosine t. So I need the second derivative. It's going to look a lot worse than what it actually is. I got two product rules here, right? Let's do this one first. Derivative of the first times the second plus the first times derivative of the second. And then I'll do the second one. Derivative of the first times the second. And I'm going to change this to minus because the derivative of the second here is going to be negative. So first times derivative of the second. It looks like I'm just writing the same thing over and over. That's what it feels like. And stuff just starts magically canceling. All right, so here I've got a times all of this. E to the t sine, actually, yes, let me cancel that before I do this. Clean it up just a bit. And there's two of these, do you agree? All right, so I've got 2 e to the t cosine t plus e to the t sine t plus e to the t cosine t equals e to the t sine t. Now they ask me what's the value of a. I can do that from here. I can subtract that from both sides. So now I have a 2 e to the t cosine t plus e to the t cosine t equals 0. What now? Subtract. I get a 2 e t cosine t equals negative e to the t cosine t. What can I do now? Divide by 2e to the t cosine t. 2e to the t cosine t. Cancels, cancels, cancels. I've got a equals negative. Everything's going up top. I hold the place for the 1, and there's a 2 on the bottom. Crazy that all those trig functions cancel down to just negative 1/2, right?